I'm gonna quickly do a 3-minute summary to this. So the momentum is represented by small letter p, and then it equals mv, mass of the object times velocity of the object. Very, very important. Now, I also explained what momentum is like in layman terms. Like if my 5-year-old uh, brother asks me, bro, what is momentum? What are you gonna say? Are you gonna say, momentum is p equal to mv? You'll be like, chief, what do you mean? What is that? You understand? You need to explain it so that they can like, understand at their level. Okay? I was saying this to Thingy earlier that Einstein says that if you can't explain something to a toddler, then you don't understand it. So, what is momentum? Momentum is the quality of motion. What quantity or quality of motion? Think about it this way. I used this example earlier. It's a bang. This is a bicycle, and this is a lorry, like lorry ele kgolo, that long thingy truck. Okay, sharp. They're literally on the same sort of line. Okay, now this bicycle is moving at 60 kilometers per hour, or let's just say 60 meters per second. This is also moving at 60 meters per second, right? Sharp, sharp. This is of mass 10 kgs. This is of mass 1,000 kgs. Now they're moving at the same speed. Okay, moving at the same speed. Now let's just say we apply brakes here. We apply brakes so this thing stops at this instant. Ne? We apply brakes for this truck, and this brakes ke brake I wanna get minus 10 newtons. It's brakes, I gotta it's just frictional force. You wanna stop it. You step the gas minus 10 newtons. You do the same here, press the brakes minus 10 newtons. You will find that this bicycle will stop maybe somewhere here at this level, while this truck will stop somewhere there. Why? Because this truck has more mass. It'll take more time for the force to put this whole thing to a stop because it's got more mass. That quality is called momentum. We say that the truck has more momentum than the bicycle. The truck has more momentum than the bicycle. Remember the formula for momentum, right? So the momentum of the truck of the bicycle is velocity is 60, while the mass is 10 grams, so it will be 600. Momentum, while kg meters per second, while the momentum of the truck will be same thing speed, yeah, but mass is different. It will be 1,000. So therefore, it's going to be 60,000 kilograms meters per second. Are you happy with the definition of barking momentum? Yes, sharp. And then I went ahead and introduced Newton's second law. You know it from grade 11. Newton's second law says F net, not just F, not F equal to ma. No, 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 no. That's a lie. You get sued for that. F equal to ma. No, that's not Newton's second law. That's someone else's law. We don't know whose law that is. It says F net equal to mass times acceleration. That's the law. This thing has a meaning. The meaning of this means like all of the forces acting on an object. I use an example. I'm like, take this trolley. Yeah, this trolley is moving in that direction, and there was a force of 5 newtons applied onto it. Right, the force applied, and then obviously since this object is moving on sand, and sand resists motion or movement, there's a frictional force of minus 10 newtons there, right? And yeah, so that's the two forces acting on the object: applied force and frictional force, force applied and frictional force. Okay, but now this object, because it's got weight, it also weighs on the ground, like on the sand. For example, let's just say I were to put you were to lie down and I put your back here, and I put a trolley like on your back. You'd feel what it's got weight, so that sort of force, like weight, that the object exerts onto the ground is like weight. That's a force of gravity. That's mg, mass times 9.8. I get it. Now Newton's, so that's another force. Newton's third law says, sorry, a third law, yeah, says if an object exerts a force onto another, then that object exerts the same amount of force but in the opposite direction. So now, since this trolley exerts a force downwards of mg, the ground will also exert the same force mg but in the opposite direction. Those two forces will cancel each other out. So basically, under force net, so to speak, loosely speaking, you could say if you're dealing with this with this sort of scenario, I'm gonna clarify something very important. I forgot to clarify it. So we're gonna go. They're looking for acceleration. The question says find the acceleration in this situation. You're gonna go F net, right? F net includes force applied plus frictional force plus force of gravity plus normal force equal to mass is 2 kgs, 2a. We're looking for acceleration, right? Now, I didn't clarify this, but I'll just clarify it now. The force applied will be 50. We're taking the right direction as positive. So it's 50 minus frictional force is 10. Then force of gravity is mg. Then this is minus mg, so they'll cancel each other out. Then we're gonna make a the subject of the formula, so it's gonna be like when you simplify this, these ones will cancel. A will eventually be 20 square meters per second. Now, what I didn't clarify here is that whenever you're dealing with the formula or trying to apply this formula of F net, if a force is at right angles with the direction the object is moving, that is, we know this object is moving this direction, while normal force is acting in that direction, force of gravity is acting in that direction. So if a 90-degree angle is created between the direction the object is moving, and a 90-degree angle is created between the direction in which the object is moving and any force, you don't count that force in the F net. It's automatic. It's deeper. It's very deep, but that's how you should look at it. Whenever the force that you want to put in force net is at 90 degrees angles with the direction of this moving object, then you don't put it in the F net. So that's why this we're not supposed to put there. So basically, F net in this context would be F applied plus F frictional equal to 2a. Are we all happy with that? Delicious. If I'm moving too fast, you just let me know. I know that I'm moving fast. Someone said yesterday that I'm moving slow. So I just put on some acceleration a bit, constant acceleration. Okay. Yeah. So that's about that. Nkhoeng is happy with the FNet story. Then I said, guys, why am I sort of showing you Newton's second law, even though we're dealing with momentum? Like, why am I showing Newton's law if we're dealing with momentum? Why? Momentum. Why, bro? Why? So the reason why it is because of this, let me show you. So here's the F-net, second law of Newton, right? Then we know that A, acceleration can be expressed or has this formula, delta V divided by delta T, right? So which means that I am allowed to replace this A there from this formula by delta V over delta T. And we know that delta V is just V final minus V initial. So this will be our formula. Then we go ahead and multiply out the M. So this will give us mv final minus mv initial. So we know that mv is momentum. So therefore this momentum final, this momentum initial of an object. And this is time. Okay, that's what it is. So you can even re-express this. Re-express this as change in momentum. Basically momentum after minus momentum before, or momentum final minus momentum initial over delta time. Okay, so that's how we can also re-express this thing. Now, to make you, or rather to get you to have a firm grip on this formula, I gave you guys a question that you're going to do in the next 5 minutes. I'm going to give you 5 minutes to do it. The question says, a bullet of mass 2 kgs is moving at 300 meters per second to the right. You need to draw the diagram yourself so that you understand. So I'm not going to draw it for you. I want you to visualize it. The bullet is moving of mass 2 kg, moving at 300 meters per second to the right. Let's take right as positive until it hits the brick wall and deflects back in the opposite direction at 175 meters per second. We understand what's going on there. This is 175. The bullet was in contact with the wall for 0.2 seconds before it changed direction. Okay, so this is the delta T basically. Calculate the net force experienced by the bullet when it changed direction. I'm giving you guys 5 minutes. If you don't understand, if anything's not clear, figure it yourself out. I'm gonna pause for 5 minutes. I'm gonna be silent. While I'm silent, I'm gonna fetch my thingy, my charger, and my notes. I left my notes somewhere for the session. So 5 minutes. Time now is 35 past 7. It should be done by 40 past 7. Any questions before I pause?